So a couple problems from section 8.5. A couple people talked about in problem number 1 that you could have used trig substitution and you would get an answer that looks different. And that's definitely true. You could have used trig substitution and your answer will look a lot different than what mine was. And that's okay. So you don't have to worry about that. So then the problems that people did have questions on besides that were problem number 3. So number 3 was the integral of dt divided by t cubed plus t squared minus 2t. So the first thing that we're going to need to do when we do partial fractions here is we're going to first need to factor that denominator. So I could take out a t, so this would be t times t squared plus t minus 2, and then that factors into t plus 2 times t minus 1. So what that means is that our fraction is going to end up being 1 over, I have t times t plus 2 times t minus 1. So we're going to have a over t plus b over t plus 2 plus c over t minus 1. And then I'm going to multiply the whole entire fraction by t times t plus 2 times t minus 1. And if I do that, I have 1 is equal to a times t plus 2 t minus 1 plus b times t minus 1 plus c times t plus 2. Okay, and then I'm going to pick some values of t to plug in to find my a, b, and c. So one nice value to plug in would be t equals 0. So if you plug t equals 0 in, we have 1 is equal to a times 0 plus 2 times 0 minus 1 plus b times 0 minus 1 plus c times 0 plus 2. So this second piece goes to 0, this third piece goes to 0, and I'm just left with 1 is equal to a times 2 times negative 1. So 1 is equal to minus 2a, so a is going to be equal to minus 1/2. I'm going to slide the problem up here. If I'm trying to find, so I can also use t equals positive 1. So 1 is going to be equal to a times 1 plus 2 times 1 minus 1 plus b times 1 minus 1 plus c times 1 plus 2. So this time the whole entire a term is going to go away, the whole entire b term is going to go away, and so we're left with 1 is equal to c times 1 times 3, so 1 is equal to 3c, so c is going to be 1/3. And then finally, if I pick t equals negative 2, that'll make some things go away. So 1 is going to be equal to a times negative 2 plus 2 times negative 2 minus 1 plus b times negative 2 times negative 2 minus 1 plus c times negative 2 times negative 2 plus 2. So in this case, a goes away and c goes away. And I have 1 is equal to b times negative 2 times minus 3. So 1 is equal to 6b. So b is going to be equal to 1/6. So what that tells me is that if I come back to my beginning here, this is going to be the same as the integral of a, so minus 1/2 over t, plus b, which we said is 1/6, so 1/6 over t plus 2, plus c, which we said is 1/3 over t minus 1 dt. So let me copy this integral to the next page. Okay, so this is the integral that we now need to integrate. So all of these is that trick I showed you guys. So this is going to be minus 1/2. I have essentially 1 over t left, so that's going to be the natural log of the absolute value of t, plus 1/6, the natural log absolute value of t plus 2, plus 1/3, the natural log absolute value of t minus 1, plus c. And again, it's just using that trick that the integral of 1 over x plus or minus a dx, or t's, whatever you have, is always going to be the natural log of the absolute value of x plus or minus a. So that's what I used there. Okay, so the next problem is problem number 4, which asks for the integral from 0 to 1 of dx over x plus 1 times x squared plus 1. So it's already factored. Oops. The bottom is already factored for us. So we're trying to split up 1 over x plus 1 times x squared plus 1. So that's going to be a over x plus 1 plus bx plus c over x squared plus 1. So if I multiply the whole entire thing by x plus 1 times x squared plus 1, we're going to end up with 1 is equal to a times x squared plus 1 plus bx plus c times x plus 1. And so I know I did it a different way on the sheet, but you can easily get one of the values. So if you plugged in x equals -1, that would get us one of the values. So 1 would be equal to a times -1 squared plus 1 plus b times -1 plus c, all times -1 plus 1. So if we did that, this whole term is going to go to 0. So we have 1 is equal to 2a. So a is going to be equal to 1/2. We could have gotten, so we could use x equals 0 for another point. So 1 would be equal to a times 0 plus squared plus 1 plus b times 0 plus c times 0 plus 1. So in this case, 1 is going to be equal to a. The b part goes to 0. So we're just going to have a plus c. We know a is 1/2. So 1 is going to be equal to 1/2 plus c. So c is also going to be equal to 1/2. And then to figure out b, we need to just plug in another value. So maybe we'll try x equals 1. You could equate the coefficients like I did on the homework solution, but I figured I'd show you guys a different way. So if I plug in +1, 1 is going to be equal to a times 1 squared plus 1 plus b times 1 plus c times 1 plus 1. So 1 is going to be equal to 2a plus b plus c times 2. So 1 is going to be equal to 2a plus 2b plus 2c. So 1 is going to be equal to, so a is 1/2, so 2 times 1/2 plus 2b plus c is 2 times 1/2. And so if I do that, I'm going to get 1 is equal to 1 plus 2b plus 1. So 1 is equal to 2 plus 2b. So -1 is equal to 2b. So b is going to be equal to -1/2. So my integral from 0 to 1 of dx over x plus 1 x squared plus 1 is now going to turn into the integral of a, 1/2 over x plus 1, plus b, which is -1/2 x, plus c, which is 1/2, all over x squared plus 1 dx. So let me copy this, and let's take this to the next page so that we can work on it. Okay, so I'm going to split it up a little bit more. So this is going to be the integral, I should say 1/2 the integral of 1 over x plus 1 dx. That's easy enough to integrate. Plus the integral of minus 1/2 x over x squared plus 1 dx. Plus the integral of 1/2 over x squared plus 1 dx. And so now I have these three integrals to work out, and they're all between 0 and 1. So once I figure out what we're doing, then we'll have to plug in 0 or in 1. Okay, so the first integral is easy enough to integrate. And let me leave some space. So this first integral comes down to be 1/2 the natural log the absolute value of x plus 1. On the second integral, we're going to have to do a u sub, so let u be equal to x squared plus 1. Du is going to be 2x dx. So I need to multiply the top here by a 2, which means I need a 1/2 out in front. So we're going to end up with plus, I have the blue 1/2, that minus 1/2 comes out in front. And then whoops, I forgot, I want to kind of get it done so it can fit in here. So we have that blue 1/2, then that minus 1/2 comes out in front, and we're left with the integral of 1 over u du, and the integral of 1 over u du, so I've got minus 1/4 natural log absolute value of u. So let me pull this down a little bit further. So we're going to end up with, and rather than a plus, we're going to have a minus. So minus 1/4 the natural log absolute value of x squared plus 1. And then finally, so the last integral, you could do a trig substitution on it, but it is just the definition of the inverse function of one of the inverse antiderivatives. So this is 1/2 the integral of 1 over x squared plus 1 dx, and the integral of 1 over x squared plus 1 is the inverse tangent. So this is going to be 1/2 the inverse tangent of x, and then we're going to evaluate it off from 1 to 0. So plug in 1, so 1/2 natural log of 2 minus 1/4 natural log of 2 when I plug in 1, plus 1/2 the inverse tangent of 1, minus 1/2 the natural log of 1, minus 1/4 the natural log of 1 when I plug 0 in, plus 1/2 the inverse tangent of 0. So natural log of 1 goes to 0, natural log of 1 goes to 0. So we have 1/2 the natural log of 2 minus 1/4 the natural log of 2 plus, so the inverse tangent of 1 is pi over 4, so I have 1/2 times pi over 4 minus 1/2 the inverse tangent of 0 is 0. So we end up with 1/2 the natural log of 2 minus 1/4 the natural log of 2 plus pi over 8. And you could leave your answer like that. I did do a little bit more algebra on the homework problem to simplify it, but I'm okay with you leaving the answer like that. Okay, so the last problem that people wanted to see from this section was problem number 5. And so problem number 5 asks for the integral of 2x cubed minus 2x squared plus 1 all over x squared minus x dx. And so the first thing to notice is that the power on the top is higher than the power on the bottom. So I can't do partial fractions until I do long division. So the first thing I'm going to do is I'm going to do long division out. And so if I take the 2x cubed minus 2x squared, oops, I did not leave myself enough room here, plus 1, and I'm dividing it by x squared minus x. So the first thing I'm going to do is I'm going to compare 2x cubed with x squared. To get 2x cubed, I need to multiply x squared by a 2 and an x. So if I multiply it down, 2x squared times x, 2x times x squared is going to give me 2x cubed. 2x times minus x is going to give me minus 2x squared. And then if I subtract that all, I'm going to just be left with the 1. And so there's nothing else that I can do with that. 1 is my remainder. And so what that means is that this is really equal to the integral of 2x plus 1 over x squared minus x dx. So those are the things I need to integrate. Now integrating 2x is easy. I don't have a problem. Integrating this, I'm going to need to use partial fractions. So x squared minus x, I can factor on x. So I have x times x minus 1. So if we do the partial fractions strictly just on that part, 1 over x squared minus x is going to be equal to a over x plus b over x minus 1. Remember, x squared minus x is just x times x minus 1. If I multiply this whole entire equation by x times x minus 1, we end up with 1 is equal to a times x minus 1 plus bx. So if we let x be equal to 1, we get 1 equals a times 1 minus 1 plus b times 1. And so this part here goes to 0. So we end up that 1 is equal, So we end up that 1 is equal to b. If I pick x equals 0 and I plug in, I end up with 1 is equal to a times 0 minus 1 plus b times 0. So 1 is equal to minus a. So a is going to be equal to negative 1. So my integral now looks like the following, right? So my integral is now going to be, I'm integrating 2x plus a over x, which is negative 1 over x, plus b, which is 1 over x minus 1 dx. And so if I integrate those, the integral of 2x is x squared. It's 2x squared over 2, the 2's would cancel, minus the natural log of the absolute value of x plus the natural log of the absolute value of x minus 1 plus c. And so that's the last problem that you guys wanted to see. So hopefully that helps out on those problems.